Assume that I have to do a set of standard pendulum in order to find its time period and damping constant by some method. Uh, in this room, where do you think can I do that setup? I mean, assemble that. I mean, first the constraint is it's a magnet, so its north and south pole need to be aligned with the Earth's magnetic field, because if it is not aligned as such, it will start doing elliptical motion about magnet its aligns mean. In this position, in this orientation it aligns finally. So I need to have my racket in this orientation, and I'm not able to find any stand which is on this wall or on this wall, on which I can like keep it like this and then fix it with sessile tape or stuff like that. So the thing that I have planned out is I will do a simple setup of pushing my racket inside this drawer and partially losing it, so that now it is like arguably stuck, and now the magnet is like perfectly aligned with the Earth's magnetic field. And this way I can show you from the top. So if you see, it is like perfectly aligned like this. So this direction is the Earth's magnetic field going, and now I can find the separation between the ground and the magnet, and I can find the damping constant and start doing. So finally my setup is done, and this is how it looks. This is the device from which I will be recording this secondary video, in order to track it on the application tracker. And this is the magnetic pendulum, which is over a aluminum seat, which will provide the damping. The air will also provide the damping, but the Lenz's law and the other stuff will provide a greater magnitude of damping. This is the protractor print, and I also have markers on this magnet and also near the hinge, in order to find the length of the pendulum, which I will do afterwards. And I also have this ruler, so that I can have a proper uh, 1 centimeter to feed into the tracker, so that it knows how a 1 centimeter looks like, which will be actually done from the device, which is this one. That's why it is recording a video, by the way, if you ever wonder. A secondary video, I mean. Well, this is the app that I will be using in order to trace out the curve and to trace out the points in short. And you can actually download this app from the internet, and the link goes like this. I hope it focuses. Okay, so yeah, and you can download it for Windows, Mac OS. The interface looks something like this. So from here you can actually bring the video that you want to trace, and then the video pops out here. And then what you can do is you can go to this calibration section, like this small little blue color logo, and from that you can actually bring a calibration stick like this, and you can zoom in and calibrate your 1 centimeter like this. So this one here. So from 4 to 5 centimeter I've calibrated it as 1 centimeter. Oh, wait, I can actually change the unit here also. Okay, cm. So yes, I want to change it. So it is now changed to 1 centimeter. Yeah, 1 centimeter. So the calibration is done for the length part. Now for the coordinate part, I can actually assign the initial mean to be 0 by dragging this coordinate part, which can be procured from this purple color symbol here. And when you click that, you get this crossed coordinate system. Now you can drag this middle portion and uh, perfectly align it with the mean position of the pendulum. And if your camera is kind of twisted and all, then you can, what you can do is like you can twist this coordinate axis, which is yeah, like this. You can rotate the coordinate axis to for my case I will keep it like this, which is approximately 0.2 degree. Now we are all set to go. Like, now what you need to do is you need to press this zoom to the particular position that you want to trace, and now you can press this track button, new point mass, and you can actually press this shift key and use the mouse in order to uh, pinpoint where the particle is. Like, I will do one and show you how it's done. So I have pressed the shift key with this mouse, and I can press the click button from here and see what it does. So when I click the mean position, okay, I don't want to do the mean position. Wait a second. This is the position from which I want to measure my. I want to start my tracing, and for that I just move this little hook kind of thing from the first to the position from which I want to measure, and I also move this black portion from here to here, and the end is like here, as denoted by this upward facing triangle. And now press the shift key and ready to begin. So when I press the, like, this is the first case, first frame, reassign this frame as the first frame due to this black triangle. And when I press the center like this, it immediately switches to the next frame, and from here I can actually change how many frames it will jump. So for now I will keep it as 3 frames jump. So 0 is here, and then second frame is here, third frame it is also here, fourth frame it is also here, fifth, sixth. Yeah, so now I left. Now I can start. Like, the images are fuzzy, but for that you need to have a high frame rate camera, which is actually hard, but I did not want to do that because in that case the loading time for the computer would be like huge, and I don't want to like it to run for so long, because I need to end it real soon. So I've just done it with normal frame camera, which is like my tab camera, and that is around like 30, not even 30 frames per second, I think, whatever it is. So the point that I'm trying to make is, like, if you have a high frame rate camera, you will have this uh, less jittery kind of thing. This, it is not a particular instant of time. It, like, the frame actually captures few instances of time and not just one instant of time. That's the point that I want to make. Like, now let's come to the fitting part. For fitting, we will be using Excel sheets, and in this sheet I have mentioned only those maxima points, I mean only amplitude in one direction, because I mean you can also put the values for minimas, and in that you need to actually uh, change the negative sign to the positive sign. I mean in short, put mods, because amplitude is positive quantity. I mean we assume it to be positive, so we need to put mod. Then we will create a fit section, and in fit section we will use this formula. This formula is quite simple. It only talks about exponential decay curves, which is evident from how it looks. For now, we will be just randomly assigning a value for alpha, which is also the ramping constant in our case. And then we will create a final section, I mean final column, which goes by the name of chi squared. And chi looks like this. And for the column, we will be using this formula. This is the general formula, right? Like we uh, subtract the expected, I mean not expected, but the measured value from the fitted curve, and then we square it. Then we get chi squared, and then we sum all the chi's, and then we try to minimize it in order to find the best fit for our data set, and that determines alpha in this case. We will sum those chi squared values in some other cell by using this formula. This is a general formula by which you can sum a few cells together in Excel. Finally, we will be using the solver option in order to minimize the sum chi square, which will change the values of alpha and check for every value of alpha uh, for what value of alpha the chi squared sum can be minimum, and it pops out those values, and it changes the alpha that we have assigned initially as 1 to that value, and sets our curve actually, and this is the fitted curve.